Hi everyone, this is our project video for our final project, which is Talk to Nerve. First off, for our problem, the problem we are addressing for the project is text-guided nerve scene editing. First off, let's introduce the concept of nerves or neural radiance fields. Nerves are essentially neural networks that can render 2D images given the camera perspective of a 3D scene. The neural network is generated using the images of a different perspectives of a 3D scene and is able to produce unseen perspectives in the original image set. Obviously, nerves will provide a novel way to preserve 3D scenes using only 2D images. So what is our problem with nerve? Imagine we have a 3D scene of a table with an apple on it. It is naturally for us to want to change the scene directly. In other 3D object formats, we may be able to directly add or remove objects from the scene, say the apple, but it will be impossible to directly delete the apple from the table by editing a neural network, as the neural network cannot be semantically understood and directly relate to the components of a 3D scene. So for our project, we want to re-implement a state-of-the-art paper on text-guided nerve editing 01230 shot 1 image to 3D object, which my teammates, which I will elaborate later. We're also working in progress on fine-tuning the model using an annotated 3D object dataset. As we can see below, the instances in the dataset includes both single object like a Batmobile and a complete scene featuring multiple objects like the Greenwich Observatory. Since the fine-tune is still in progress, we haven't evaluated the fine-tuned version, and our presentation will focus on the current implementation. For the method, we propose the following pipeline. First off, we have a language guide edit using a diffusion model or dream stable diffusion. And then we want to use a multi-angle transformation or maybe a single image and then feed it into a 3D reconstruction network, which is similar to the original nerve model for our final nerve scene reconstruction. Okay, so first let's dive into the language guided edit part. As for language guided edit, we consider several ways to create a simple tap and addition done system, such as create a 3D nerve model and utilize special embedding combined with large language models. However, we find that this approach is not only too complex and beyond our computational resources, but also lack the efficient, concise, and clear technical elegance. In the end, we decided to use a language model exclusively for editing images, which are used in the following reconstruction to achieve a simple and efficient system. Given an input image and a target text prompt, we train a generator and leverage a pre-trained clip model to generate an edit layer that is composited over the original input. This allows us to constrain the generation process and maintain high fidelity to the original input by losses that are applied directly to the edit layer. Compared to the directly editing with a 3D model, this method alleviates concerns about the geometric alignment issue and the potential loss of the perspective in editing effects. And this slide gives a sample output of our first part, which is the stable diffusion model with text editing of an image. Next, let's dive into the pre-trained dream stable diffusion and nerve, which is the second part of our pipeline. Given the picture that they edited under language guidance, we apply a novel method to shift a camera's viewpoint from a single image. Using Dream Stable Diffusion pre-trained diffusion model introduces a process where Gaussian noise initiates a transformation within a latent diffusion model. This leads to an output view, a new perspective of the original image under supervised learning. It is used for optimizing 1 to 3D nerve reconstruction guided by the model learned geometric priors. The result is a sophisticated 3D reconstruction from one single flat image crafted in under a minute of processing. For our baseline, we decided to use Sign, which also supports text-guided nerve editing. Since it's partially open source, we can only take a glimpse of the results visually. Note that since the baseline paper we chose does not have any qualitative results, we do not have any qualitative comparisons as of now, but we will try to find other metrics for our project. And this current results back to our original task, which is to convert a single car into chocolate edit. You can see that our current project can kind of generate views, but are not that ideal. And since our fine-tuning is still in progress, we expect better results for our final report. In conclusion, our problem is editing a nerve scene using text instruction, and our approach is to use diffusion to generate new images based on text instruction and use single image nerve generation for reconstructing the nerve scene. And our results are only visual results at the moment, and our fine-tune is still in progress, and we'll expect better results and qualitative metrics for our final report. That's all. Thank you.